Welcome to A Moment of Science, Please. I'm one of your hosts, Hawwa.
And I'm your second host, Aghia.
Today we have Dr. Singh on our podcast, who is a professor in the Faculty of Medicine within the Department of Immunology. Welcome, Dr. Singh. We're delighted to have you. If you could please introduce yourself and tell our audience a little bit more about you and your background in education and what really interested you about the fields of your study.
First of all, I just wanted to say thank you guys for having me. So my name is Jasty Singh. I'm currently an assistant professor in the teaching stream with the Department of Immunology at the University of Toronto Faculty of Medicine. I'm also now the associate chair for undergraduate studies within the department. And in my roles, I predominantly teach a variety of introductory immunology undergraduate courses. But over the past year, I've also developed and ran 2 new courses that I created, one at the undergraduate and one at the graduate level. And these both focus on bridging immunology with statistics. So in terms of my educational background, much like the audience for this podcast, I began my education at the University of Toronto. I was an undergraduate student, double majoring in human biology, health and disease, as well as immunology. And I always like to be open and admit that I had a very tough time in my undergrad. My grades were subpar, they were okay, but with exceptions. So I loved and I thrived in immunology courses. And that was just because they made sense to me. And so this inspired me to always think about how what I was learning was applicable to my daily life. And so immunology became really cool throughout my undergraduate program. So this led me to apply to the graduate program in immunology with the Department of Immunology at U of T. And I ended up doing a PhD in Dr. Juan Carlos Zuniga-Fluker's lab. And I'll talk a little bit about my research interests later, but largely we focused on a specific type of immune cell called the T cell. And I was looking at a lot of preclinical animal models for studying T cells further. And then after my PhD, I was sort of at a crossroads. So I was considering going into either industry, so working at a company, or staying in academia. And during my PhD, I had excellent opportunities to teach and mentor. And that was an interest that I felt was still underexplored coming out of my PhD. So long story short, at the time, I was also recruited to a bioengineering lab for a potential postdoc. And this was with the Institute of Biomedical Engineering at U of T. And I decided to say yes, because I was the only immunologist working with a team of bioengineers. And that was something that was new and that was exciting for me. But while I was doing this, I was also able to continue with my teaching interests. And come full circle, I am now a teaching faculty member, and I decided to come back where I trained, which was the Department of Immunology. So yeah, that's a little bit about me.
You're a real U of T lifer.
I'm a real U of T lifer, but it just goes to show it's not because I've been at U of T my whole life. I think that's something to be said about the excellent training at U of T as well.
Well, thank you so much for sharing that with us. I mean, you have such a amazing background, such a diverse background, and we're so excited to have you here. So this kind of brings me to our next question. So as you may already know and kind of like hinted towards in your answer, compared to some of our guests, you're not currently doing research, correct? But we do know that you've done research previously. So would you be able to brief us and our audience a little bit about some of the previous projects that you've worked on?
Yeah, so I alluded to this a bit earlier. I did my PhD in a T cell lab. And what I was specifically focused on was studying T cells in cases where they were absent. So that's something called a T cell immunodeficiency. And clinically speaking, we see that a lot with given diseases and disorders, such as HIV infection. So HIV is a virus that destroys T cells and T cells are missing. We also see that after bone marrow transplantation. So normally when individuals receive stem cell transplants, a lot of their immune cells come back. T cells are slow to recover or they may never recover. And so I did a lot of my work in preclinical mouse models, and these were immunodeficient mice. We were looking at approaches to restore the T cell response And that was kind of a really exciting idea because at the time, T-cell immunotherapy, so using T-cells for therapy, that was becoming an exciting idea in the field. And T-cells were these important cells that a lot of researchers were looking at for these therapies. And so as I was finishing off my PhD, as I mentioned, I was recruited for my postdoc in Dr. Peter Zanstra's lab, and I decided to pivot my work a bit. So working in the stem cell bioengineering space was really cool. I worked as part of a team that wanted to engineer immune cells, and specifically T cells, and also develop clinically relevant biomaterials to help enhance T cell generation artificially, all with the purposes of immunotherapeutic application. So I've really focused on T cells my whole research career, but from different capacities, whether it's thinking about T cell immunodeficiencies in preclinical mouse models, or whether it's thinking about how to engineer the cells themselves or the environment in which they thrive. And I don't do typical life sciences research anymore, but in my current role, I do some research, and it's called pedagogical research. So it's education-related research. And a lot of this research is an ongoing collaboration with Dr. Bethany White from the Department of Statistical Sciences. And collectively, we're sort of interested in exploring how we can best prepare undergraduate student researchers to engage with statistics and research, which I think will be the basis of our discussion today.
Yep. So, I mean, I think it's very interesting that immunology, well, as a field, connects to like engineering and then statistics as well. Like it's just very, like it's very webbed out, I guess. And you don't hear a lot of people like when you major, when you specialize or minor, you're not thinking like what else can I apply this to. So I think it's really cool that you were able to do that and like diversify what you were able to learn.
Absolutely.
So you're an active member in the Department of Immunology, and you're a professor in the Department of Statistics, like you just talked about with your course development. What made you want to focus more on teaching rather than research?
Yeah, so that's a really great question. So I loved research, and I still love research, and I find ways to stay active in life sciences research, whether it's through advising or whether it's through co-supervisions. But one of the things, having gone through a very extensive research career, that I decided to reflect on was what I loved most about it. So when I think about why I decided to pursue my current career in teaching, it comes down to a few things. The first is the value of mentorship. So I was very fortunate to have excellent mentors throughout my PhD and my postdoc training. And these were mentors that really allowed me to have freedom and explore my interests in a lot of ways. So I owe a lot to them. But I also had a lot of education related mentors. So a lot of individuals that I was working with in the human biology program or the Department of Statistical Sciences. These were individuals that helped me understand my identity and kind of what I enjoyed as part of my PhD and postdoc training. The other thing is the value of mentorship has been so pervasive in my own career, or in my own, I guess, education. So as an undergraduate student, I said I struggled a bit, but it was, very few people that take a chance on a struggling student. And so I always, felt like I wanted to be that person for other students coming into my classes. I enjoy inspiring others about, research, but also about immunology and about learning in general. So I feel like I'm able to do that well in my current role as a teaching stream faculty member. And the last thing, and I think an important consideration, is lifestyle and flexibility. So I love that I have the ability to teach, or the flexibility to teach courses, create courses, but also continue to grow in my own way. So I am actively always trying to pursue, other forms of education. I'm able to pursue my own research, whatever that may be. So in this case, I'm focusing on, again, statistics and life sciences and bridging the two. But I guess the long story short is I'm always growing, and I love that.
Yeah, I mean, that's a very well thought answer. Thank you for bringing up the mentorship point, because I personally think that without mentorship, my like journey U of T would have been totally different. So I do know that mentorship can make a lot of differences. So thank you for bringing that up. And also, like, as maybe we talked about before, one of the goals of our podcast when we started it is to like introduce a student to different career path that they can follow when they get their degree. So it's great to have such like different answers from our guests about their career choices. And again, we talked about this before. You do know that Hawwa and I were in your classes before. So as former students of yours, we know that the emphasis on data and statistics and research is a recurrent theme in your lectures. Can you please tell our audience a little bit about the importance of statistical consultation and research, and the negative effects of overlooking this importance on the findings of research projects?
Yeah, so I'm really glad we're talking about this. So I openly wanted to start by saying I am not a statistician and therefore I'm not a statistics expert, but I have been a researcher for a very long time. And so time and time again, I've gone through this process of scientific inquiry. And that's that process where, you start with an experimental question and a problem, you devise this plan to address it, you analyze or collect some data, proceed to analyze it, establish conclusions, and hopefully those conclusions will then reinforce formation of, a new or reformed research question. So throughout this entire process, I think as researchers, and I'm guilty of this myself, we tend to think of statistics as being important just at the analysis stage. Once we've collected our data, once we have it all, and now we want to see what's statistically significant or is meaningful. And one of the things that I've realized is that this is inherently problematic. So there needs to be a bit of a culture shift where we don't just see statistics as tools to apply to our research, but we actually view it as its own individual field of expertise. And so, again, I'm not a statistician, but if you were to look at the statistics process, it very much aligns with that idea of scientific inquiry. And so with that being said, I think it's very important to have statistical consultation, not just at the analysis stage, but from the very start of any research project, as soon as you're thinking about, a specific question and then devising an experimental plan that aligns with that question, collecting data, etc. I think this helps reinforce reproducible findings, which there's a huge reproducibility crisis out there in the literature, as many of us may know. But the negative effects are, one, an inability to reproduce sometimes. But if we kind of think about this broadly, thinking about the scientific inquiry process, I mean, whatever comes out of a given study helps reinforce new research questions for other individuals in the field. And if studies are not statistically sound, or if we're thinking that findings are perhaps statistically significant when they may not be in reality, I think this really kind of runs us down directions that may not be correct to pursue as researchers. And so I think inherently the negative effects are just, we may be pursuing false leads as researchers. So we do need to be very careful about how as a scientific community we're engaging with statistics and research, and also being producers of research that involves statistical analyses.
So yeah, everything you've said is true for sure with research and having those stats be equally as part of that research project. But a lot of students don't like statistics. So why do you think stats get such a bad rep just in general? Like, do you think it's because it's hard, or is it because it's boring, or is it because it's just not seen as an equal opportunity?
That's a great question. So I know you guys are my previous students. We've discussed this a little bit, but I think among life sciences students and researchers, statistics can be intimidating. And I think a lot of statistical theory is embedded in, things like calculus and math. and even computer science more recently with, having codes to automate processes and analyses. I think all of these are very far off skills that we don't necessarily teach all of our life sciences students. And I think life sciences students find them intimidating or different from their typical biology or immunology or chemistry courses. So I think there's an intimidation factor involved for sure. But I also think statisticians and life sciences researchers don't always speak the same language. So I will say that one of the things that we've recognized is this difference in kind of speaking the same language exists. And so myself and Dr. Bethany White in the Department of Statistical Sciences, we've created a course called Stats 288. And that course is really geared towards statistics and scientific inquiry in the life sciences. So it's really about making things digestible for life sciences researchers, taking statistics and applying it to examples of what you would see in the literature. And I think just through learning by example in a way that's kind of more digestible, students do find our course hopefully a little bit more easy to digest and a little bit more exciting in terms of starting their journey with regards to engaging with statistics.
Yeah, I know Aghia has taken that course. I took an easier route and I took the other stats. Partly because I didn't know about it, partly because I assumed it was going to be harder because there was like the science component, but I now regret that. I feel like it might have been a little bit more beneficial to me to take stats 288, sorry. But in terms of stats itself, what measures do you think can be taken in order to reduce the statistical error rates in life science research? As you mentioned before, with the not speaking the same language, there's definitely errors that can arise. So what can we do to minimize that?
Yeah, I mean, this is a loaded question, and I guess I'll start with kind of where we left off. I think what we can do, both yourselves as well as myself, as a researcher, is require ourselves to take statistics, right? So there is a shift towards this at the university. More and more departments are requiring statistics courses as part of their degree requirements. So that's like a nice systemic change that aligns with that idea. But as students, I do highly recommend, and I think both of you have already taken a statistics course, but I do recommend that all students enroll in a statistics course. And although most of the time it's going to be a single course to start, I will say a single course is not enough to make you a statistician. What I think the key takeaway from that course should be, and often is that students become more cognizant of what they know and what they don't know. And both are equally important as they go on then to become both consumers of research as well as producers of their own scientific research. So the first thing is statistics training is important. Now, with that, I want to say there's kind of a bunch of other challenges that kind of come to play. So statistics training is important for students, but it's also important for PIs, which is not often enforced. It's also important for journals and the editors and the reviewers at journals. So you can kind of tell we're dealing with a larger systemic issue here that needs to be addressed, but training at all levels is important. The other thing I think we can do to reduce statistical error rates as a scientific community is become better about data transparency. So a lot of journals, for example, are now requiring that researchers submitting a paper are submitting all of their data, all of their raw code if they did it by coding, a detailed statistical analysis plan. And I think that's a step towards the right direction, although it's not universalized yet. And then I think the last thing, and it's kind of a funny thing, but I'll tell you guys as students, please do not Google stats. So there's so much information out there, but oftentimes there's so much misinformation out there. And I think part of the problem in the research community, and I'm guilty of this as well, is you tend to be able to absorb that information and digest it in your own way, which is not always a good thing if you're not a trained statistician, right? Or if you're not a trained expert. I think this is also kind of reinforced by statistical practice that is kind of passed down in laboratories. So I will say, do not Google and do not take things kind of at face value. If you're told to do a test, I think sometimes after you're trained in statistics, you may question some of the decisions that are made within your own labs, as an example, but do not Google. And then the last thing kind of aligning with that is statistical consultation helps. And we've talked quite a bit about this already, but it helps mostly when there's engagement of a statistical consultant at the very beginning of the research process.
Yeah, I mean, don't Googling stuff is actually a very good point. I'm a prime example of that because prior to taking a statistics course, I was doing a research project in my second year, and I didn't have any statistical background. I was just using Google to do stuff, but none of those things started to make sense until I started taking that course. So that is 100% true. Like, don't Google stuff. And so I actually remember that in one of your lectures, you did talk about, I think maybe it was the last lecture, I don't remember. You talk about this kind of measures that we can take in order to like reduce the statistical errors. But I also do remember that in your lectures, like in the course general, you and Dr. White kind of always keep telling us what to do in order to become better researchers. So I guess my next question is, as a researcher yourself and as someone who's been in close contact with university students over the past few years, what advice would you give students who want to pursue research?
Yeah, so this is like the advice I wish I had told myself when I was at your stage as well. I really feel for students right now, especially in light of this ongoing COVID-19 pandemic, because I think research opportunities have been very limited and I guess more challenging to acquire as well. And I think in order to be successful at acquiring a research opportunity, one of the things that I encourage students to do, especially over the past year where it's been a little bit of a challenge, is I think it's important to expand your viewpoint of what research can look like. So I think for a lot of students, and I know Hawwa and I have chatted about this earlier today, but I think for a lot of students, it looks like holding a pipette in a lab, working with cells, etc. That typical image of a scientist, right? But I think what research really is in essence is application of a bunch more transferable skills. And so one of the pieces of advice I'd give students is think about what those skills are and how you've acquired them through your other courses or maybe through other opportunities you've engaged with or engaged in. So one example would be statistics, right? That is an important transferable skill you can upsell when you're sort of looking for research opportunities. Another one that aligns very nicely with that is the ability to do any form of computer programming. So R coding as a language is often used in life sciences research. A lot of students at the university taking statistics courses will have some exposure to that. So those transferable skills are equally important for research, as is holding a pipette, right? The last thing that I think students often overlook is they don't necessarily see the alignment of some of their other engagements with research. So as an example, you guys here are running this podcast, and that takes a lot of leadership skills, that takes a lot of collaboration, that takes a lot of organization, a lot of communication. And all of these skills are important for research, especially if as a student, you may not have had that typical wet lab experience. You have the ability to showcase yourself as somebody who is exceptional in other ways. I'm sure through this podcast, you guys will get a lot of advice from researchers who have their own labs, which is not myself. But the one piece of advice I'll also leave you with is make every interaction personal. So as an example, I do not have my own lab, but I often receive emails from students saying, can you take me into your lab? And that's a little disappointing, only because I think if students were to make interactions personal, they would recognize after having done their research on my research or on me, that I don't have my own research program. And so I think a lot of professors enjoy when you can truly showcase your interest in their research rather than generically, wanting a research opportunity. I think passion and I think being able to showcase that passion is equally important.
No, that's great to hear, because I think a lot of the time when we're in class, we like in first year and second year, the classes are so big. I mean, I think your class with M250 was like 1,000 people in second year. So, I mean, with those class sizes that big, I think it's very hard to make personal connections with others. And so I think it's very important to take every opportunity to get to know a prof, to get to talk to a prof. I know coming to your office hours, I got to know you a little bit better. Just learning more about the prof themselves and not just looking at them as a teacher, I think that helps. Especially with cold emailing and looking for opportunities, once you figure out what your interests are, it's a lot easier to look for research instead of just applying to everything with half the effort. It makes it a lot more impressionable. It makes it a lot more personal, I guess. If you're interested.
Yeah, and I think there's a variety of resources at the university as well that will help you, for example, with framing emails. So I don't know if you want to link eventually a link to the Career Center and some of the Writing Center resources, but there are resources at this university that will help you with things like writing an email to a professor or, updating your CV to reflect research expertise or things like that. And I think that's another way to, again, align your experience with research and then again with specific PI's research efforts and research interests.
Yeah, so just to end off before we finish up the podcast, we just wanted to ask you who your favorite scientist or researcher would be and why.
Yeah, this is always tough. I hate having to choose. I definitely don't have a favorite. I think it's because I've worked in so many different spaces. So immunology, bioengineering, and sort of statistics education. So it's really hard to choose. But I was reflecting on this the other day, and I think for the purposes of this question, since a large part of my career has been in regenerative medicine and that sort of space, I'll probably give a nod to James Till and Ernest McCulloch, whom I talk about in my classes quite a bit because they discovered blood-forming stem cells, and that's been really critical for life-saving therapies such as bone marrow transplantation for leukemia patients and things like that. Interestingly enough, they've also trained subsequent generations of medical researchers, including members of my own department now and some of my colleagues. So I think they've kind of left a lasting legacy at the University of Toronto. And so I always admire, again, great mentorship and great research success. So yeah, I'll say them.
I know we said we would end off there, but I actually just wanted to reflect on the fact that I remember in M250, there was a point where you would be teaching like the history of immunology as well. And I believe there's a course on that now as well, right?
Yeah, so the course is called M221, Origins of Immunology. It's a new course in the department, was offered for the first time last year. So the 2020-2021 academic year. Great course, do check it out. I highly encourage it. It gives you a history and the context of the entire field and the incredible scientists who have helped shape it.
That's really cool. We don't usually get to learn about like the historical aspects of science. So that's definitely something different and it might be of interest to some of our listeners. So on that note, we just want to thank you once again for joining us today and helping us reach out to other students to learn more about research and learning about academia, learning about pathways that can be possible. So thank you so much.
Yeah, thank you so much for coming. We know that professors are very busy, so thank you for taking the time.
It was a pleasure to be here, guys, and you guys are exceptional students, and I imagine much of your audience is the same. So I would be happy if any students want to reach out to me personally. I'm always happy to chat about research, career directions, and things like that. Thank you again for having me.